Hello and welcome to the Studify Plus. We are talking about the subject which is network analysis और network analysis में हम बात कर रहे हैं किसके बारे में Z2 पोर्ट पैरामीटर्स के बारे में बात कर रहे हैं। 2 पोर्ट्स पैरामीटर के बारे में हमने Z पैरामीटर्स के बारे में पूरा डिटेल डिस्कशन किया। तो Z पैरामीटर्स के अब हम देखते हैं कि क्या क्या किन कंडीशंस के लिए नेटवर्क का बिहेवियर सिमेट्रिकल होगा, किन कंडीशंस के लिए नेटवर्क का बिहेवियर रेसिप्रोकल होगा। देन वी विल मूव टू द नेक्स्ट थिंग एंड दैट इज Y पैरामीटर। सो लेट्स रिकॉल दैट फैक्टर Z पैरामीटर। The agenda is to learn about Z parameters. And in Z parameter also known as open circuit parameter because you calculate the impedances by making I1 and I2 equal to 0. So if I take this as my 2 port parameter, 2 port network, if this is one 2 port network, we are calling this as V1, V2, this current is I2 and I2 current is also going inside the network. This potential is V1 and this current is I1. So we have talked about this 2 port and we have talked about this 2 port. One port is input port and another port we are having here is output port. So let's talk about this. And what is Z parameter? So Z parameter is given by V1 V2, जहां ये V1 और V2 दोनों डिपेंडेंट वेरिएबल हैं। इनकी वैल्यू डिपेंड करेगी कि आप I1 I2 का क्या वैल्यू सिलेक्ट करते हैं। एंड दिस इज Z11, दिस वैल्यू इज Z12, दिस वैल्यू इज Z21 and this value is Z22 times of I1 and I2. We have talked about this और इसके ऊपर हमने न्यूमेरिकल्स भी देखे थे ऑन द लीनियर रेजिस्टिव नेटवर्क और हमने बात की थी किसके बारे में कि जब डिपेंडेंट सोर्सेज हों तब आप इससे कैसे डील करेंगे। We have talked about it. और हमने ये भी देखा था कि if your network is completely resistive or completely capacitive network, try to convert it into the star form. तो star form में आपको डायरेक्ट आंसर लिखने को मिल जाएगा। Correct? This is our Z parameter. Now let's go for the next condition and next condition is reciprocal and symmetrical network. तो जरा reciprocal और symmetrical network का condition दिखाता हूं मैं आपको। This is condition for symmetrical network. Symmetrical network. What is the condition for which a 2 port network is symmetrical? So it's a very simple thing. If you swap the input port by output port and output port by input port, and then if you calculate the Z11 and if you calculate the output resistance, if both are same, you can say the network is symmetrical. What I am saying, let's say, first I will explain this, then we will write. Suppose this is 2 port. This is open circuited parameter, so I am making the value of I2 equal to 0. I am making value of I2 equal to 0. This value is V2 and we are calculating this. This is I1 and this is V1. So what we are calculating by making I2 equal to 0, I am calculating the ratio of V1 divided by I1 ratio. The driving point impedance of this network. This parameter is known as Z11. This parameter is known as Z11. I am calling this parameter as Z11, and this parameter is obtained by making I2 equal to 0. Correct? What is the next condition? The case 2 is what? Case 2 is this, when I am making I1 equal to 0. So we are interchanging the ports. So the second condition is this. This is our 2-port network. And this time we are making I1 equal to 0. This is your V1. But I am interested in this ratio. Driving point impedance at port number 2. I am calling this point as V2. And I am calling this current as I2. And what is Z22? So you can say Z22 is the ratio of V2 divided by I2 by making I1 equivalent to 0. So if you are interchanging the ports, you are swapping the port number 1 to port number 2 and port number 2 to port number 1, then also you are getting the same value of Z11 and Z22. In this condition, a network is said to be a symmetrical network. Symmetrical 2-port network. So what is condition for symmetrical network? If your network follows this condition, Z11 is equivalent to Z22, then a network is said to be a symmetrical network. So even if you are changing the ports, input port to output port and output port to input port, then only driving point impedance is same. If a network satisfies this condition, we can say this network is what? A symmetrical network. So symmetrical network what we are saying, we are having one port as an input port, and if this port is swapped to the output port, and the value of Z11 is equivalent to Z22, then you can say your network is a symmetrical network. Your network is what? Your network is a symmetrical network. Now one more condition for to Z parameter, and that condition is known as reciprocal network. So which network is said to be a reciprocal network? A network which satisfies the condition of reciprocity. A network which satisfies the reciprocity theorem is known as reciprocal network. And what is condition for reciprocal network? You can say if the transfer characteristic, always remember the reciprocity theorem is always related to the transfer characteristics. Means we are taking one variable from input and we are taking another variable from output. So this type of characteristics is known as transfer characteristics. So even if I change the position of excitation and load, even if I change this position, then after also if your network appears same, then you can say your network is a reciprocal network. So can I say the very important definition of reciprocal network is this. For a reciprocal network, wait for a minute. Hello. So let's understand the condition of reciprocal network, and what reciprocal network says. A network is said to be a ठीक है, आई एम विजिबल। A two-port network is said to be reciprocal if its transfer characteristics is independent to the port. If its transfer characteristics is independent to the port. And how many transfer function you can have in a two-port network? When we are talking about the Z parameter, you can only have the two transfer function. And what are those two transfer functions? अगर मैं दोनों ट्रांसफर फंक्शन की बात करूं तो एक हम बात कर रहे हैं किसके बारे में? अगर ये मेरे पास एक टू पोर्ट नेटवर्क है, इफ दिस इज वन टू पोर्ट नेटवर्क, और इस टू पोर्ट नेटवर्क में हम बात करें ट्रांसफर फंक्शन के बारे में, तो देयर आर टू टाइप्स ऑफ ट्रांसफर फंक्शन वी कैन हैव. दिस इज V1, दिस वैल्यू इज I1, एक और वैल्यू है मेरे पास V2 और I2. This is V2, this is I2, and this is our two-port network. So what we can say, one of the transfer function we can have V1 divided by I2 by making I1 equal to 0, and that parameter is known as Z12. And one more transfer function we can have, transfer function in form of impedance, means V2 by V1 is also transfer function, but we are not interested in that. V2 divided by I1 by making I2 equal to 0 is another transfer function. And what is value of this? This value is Z21. And what we can say, a network in which the transfer characteristics of this network is independent to the port, that condition is known as reciprocal network. So condition for reciprocity is what? Z12 should be equivalent to Z21 is the condition for a reciprocal network. A reciprocal two-port network, a reciprocal network in Z parameter is given by Z12 is equivalent to Z21. Always remember, a resistive network is always reciprocal. You don't have to check the reciprocity of a resistive network. You have to check the reciprocity in case of dependent source you are having in the network. So can I say point number 1, a resistive network is always reciprocal, while we have to test in case of dependent sources. Point number 2, for dependent sources we have to check. Z12 equal to Z21. We will check that condition for, what? We will check that condition for a circuit having the dependent sources. So these are two very important conditions, because in lot of question they will ask whether this network is symmetrical or reciprocal. So always remember, there is no need to change the reciprocity for a resistive network. The resistive network, as we have seen in the reciprocity theorem, the resistive network is always linear in the nature. So this is two conditions for two-port parameter, two-port Z parameter. One more thing I can write for the Z parameter is connection of the Z parameter, or I should say the series connection of Z parameter. Series connection. And what is meaning of this series connection of Z parameter? As you know that this is impedance parameter, and if it is connected in the series, then you can add the two Z parameters. So let me say, यहाँ मैंने एक Z parameter बनाया, एक two port network है यहाँ, and here we are having another two port network. These are two two-port networks, and we are having two-port network. Means how many terminals we are having? We are having 4 terminals. So we are having 4 terminals here. 1, 2, 3, 4 terminals. These are 4 terminals. Correct? Two port number, and let's say I am calling this is our, this parameter is known as Z prime. जो पहला टू पोर्ट नेटवर्क है उसके सिर्फ सारे Z पैरामीटर्स का जो मैट्रिसेस बनता है उसको मैंने Z प्राइम से रिप्रेजेंट किया है, and here I am representing it by Z double prime. This is Z double prime. Let's make a series connection of this network. तो इसका मैं एक सीरीज कनेक्शन बनाता हूं, देखें जरा. This is the series connection. लेट्स मेक ए सीरीज कनेक्शन, और यहां से भी बना देते हैं, इन दोनों को कनेक्ट कर देता हूं. दिस इज सीरीज कनेक्शन, करेक्ट. And let me tell you, this voltage is I am making series connection of this, and let's say this voltage is, I am calling this voltage is V1 prime. जो पहले टू पोर्ट नेटवर्क का जो वोल्टेज है उसको V1 प्राइम लिखा है मैंने, और दिस करंट इज नोन एज I1 प्राइम, करेक्ट. पहले ही टू पोर्ट नेटवर्क का जो दूसरा आउटपुट पोर्ट है, आई एम कॉलिंग दिस एज V2 प्राइम, एंड आई एम कॉलिंग दिस करंट एज I2 प्राइम. And let's extend this. तो ये पहले टू पोर्ट पैरामीटर के बारे में है. एंड द Z पैरामीटर फॉर द फर्स्ट टू पोर्ट नेटवर्क इज, लेट्स से दिस इज Z प्राइम, एंड दिस वैल्यू इज गिवन बाय Z11 प्राइम, Z12 प्राइम, Z21 प्राइम and Z22 prime. This is the two port parameters are given for the first network, and these parameters are given by this. We can write these parameters by this rule. What is next? The next is, we are interested in second one. So how I will write the second? I will write the second one as V1 double prime I am calling this current as I1 double prime, correct. What I am calling this, output port पे जो available है, I am calling this as V2 double prime, and I am calling this number as I2 double prime, करेक्ट. ये मेरे पास दो टू पोर्ट नेटवर्क है, और दोनों टू पोर्ट नेटवर्क के लिए मैंने टू पोर्ट नेटवर्क नंबर 1 और 2 दोनों के लिए एक सीरीज कनेक्शन बनाया है. व्हाट एल्स वी वांट टू कमेंट? वी वांट टू कमेंट ऑन दिस. कैन आई से आई एम कॉलिंग दिस वोल्टेज एज V1 and I am calling this current as I1. Just we are talking about what is the equivalent of this two port cascaded or series connection of the two port network. I am calling this value as V2. अगर इस वैल्यू को लिखूं, इस वैल्यू को मैं बोलना चाहता हूं कि this value is V2, and let's say this current is I2, correct. So we are having the data in the format which is in our standard format, where these are the standard data. Let me represent it by white pen. I1, this is V1, this is V2 and I2. So we are interested in, suppose, how we can represent this two port, the combination of two port network into single two port network. Means I want this equivalent of this. Suppose if I say this is two port network, if this is two port network, what is the equivalent Z parameter of this two port network for this network? This is the network number 1, and we want to write this is network number 1, और हम इसका इक्विवेलेंट लिखना चाहते हैं for this, and we want to convert this network number 1 into this condition. This is network number 2. So we are saying that if I represent this, अगर इस if I call this voltage as V2, अगर इस वोल्टेज को अगर मैं बोलूं I2, if I call this voltage as V1, if I call this voltage as I1, so I want a equivalent two port parameter representation of this network. And how we can write it? इसको लिखने का क्या तरीका है जरा देखिए. Okay, very basic KVL laws are applicable here. Can I say V1 prime and V2 prime is equivalent to V1? अगर आप यहां एक इनपुट में KVL लगाएं तो इस KVL में देखेंगे कि यहां नेगेटिव से आप पॉजिटिव की तरफ जा रहे हैं, तो इनपुट में KVL लगाए तो दिस पोटेंशियल इज V1 minus V1 prime minus V2 prime equal to 0. Sum of voltages inside a closed loop equal to 0. So can I say V1 can be written as V1 prime plus V1 prime plus V1 double prime. This is our first condition. And कहां से लिखा हमने? Input KVL is responsible for this equation. What next? The next is, what is current which is going inside the network? So can I say I1 dash and I1 is same thing. और जितना करंट इस नेटवर्क में जाएगा उतना ही करंट यहां से बाहर आएगा, तो यहां से आने वाला करंट भी कितना होगा? This current is equivalent to I1. Yes or no? So can I say these currents are equal? I can say I1 is equivalent to I1 dash is equivalent to, और यहां से जो करंट आने वाला है वो भी कितना है? I1 double dash. This current is I1 double dash. These three currents are equal. बड़ा बेसिक सा प्रिंसिपल है. The net current going inside the network and net current coming out from the network is same. So from that theory we have wrote these two values. So ये जो value है, these values are valid for input port. ये किसके लिए valid value है? These values are valid for what? These values are valid for input port. These values are valid for input port. लेकिन लगभग ऐसी ही कंडीशन मुझे अवेलेबल है कहां? सेम कंडीशन इज अवेलेबल एट आउटपुट पोर्ट ऑल्सो. अगर मैं आउटपुट पोर्ट को विजुलाइज देखूं, जरा एनालाइज करूं, थोड़ा विजुलाइजेशन की कोई जरूरत नहीं है. आप देखें जरा कि अगर आउटपुट पोर्ट में KVL लगाया जाए तो V2 इज इक्विवेलेंट टू V2 प्राइम प्लस V2 डबल प्राइम. सो कैन आई से द एनालिसिस ऑफ द आउटपुट पोर्ट, अगर आउटपुट पोर्ट का एनालिसिस करें तो हम आउटपुट पोर्ट में फर्स्ट ऑब्जर्वेशन से क्या लिख सकते हैं? विद द बेसिक नॉलेज ऑफ KVL, आउटपुट KVL सेज दैट, आउटपुट पोर्ट पे अगर आपने KVL लगाया तो ये V2 है, ये किसके इक्वल होगा? -2 प्लस दिस पोलरिटी इज अपोजिट टू दैट. तो अगर नेगेटिव टू पॉजिटिव का पोलरिटी पॉजिटिव टू नेगेटिव इस पोलरिटी के इक्वल है, मतलब दोनों वोल्टेजेस बराबर हैं. तो यहां मैं लिख सकता हूं V2 इज इक्वलेंट टू V2 प्राइम प्लस V2 डबल प्राइम, ये इसके इक्वल होगा. और ये भी आप जानते हैं कि किसी नेटवर्क के अंदर द करंट, नेट करंट गोइंग इनसाइड द नेटवर्क एंड नेट करंट कमिंग आउट फ्रॉम द नेटवर्क इज सेम. तो यहां I2 की जो वैल्यू होगी वो I2 डैश के बराबर होगी, और सेम करंट इज कमिंग आउट फ्रॉम हियर. तो ये जो वैल्यू होगा ये भी कितना होगा? दिस वैल्यू इज ऑल्सो इक्वलेंट टू I2 डैश, I2 double dash. If you have understood these 2 points, then we can write the equivalent. अगर आपने इन दोनों बातों को समझ लिया है तो हम बड़ी आसानी से इसका इक्विवेलेंट लिख सकते हैं. अब कैसे लिख सकते हैं इक्विवेलेंट, जरा देखें. कि नहीं से V1 प्राइम V2 प्राइम V1 prime V2 prime is equivalent to Z11 prime. अच्छा, one more thing, what is the value of Z double prime? तो Z double prime is same कि आपने सिंगल प्राइम में एक लिखा है तो डबल प्राइम में सारे पैरामीटर्स के आगे कितना लिख देंगे आप? Z11 डबल प्राइम, Z12 डबल प्राइम, Z21 डबल प्राइम एंड Z22 डबल प्राइम. ये हमने वैल्यू लिखा किसका? दिस इज द वैल्यू ऑफ दिस सेकेंड टू पोर्ट पैरामीटर नेटवर्क. नाउ जरा हम बात करते हैं इसकी. दिस इज Z11 प्राइम, देन ये Z12 प्राइम होगा, दिस विल बी Z21 प्राइम, this will be Z22 prime multiplied by what? Multiplied by अगर हाँ ये टू पोर्ट पैरामीटर में इस नेटवर्क के लिए लिख रहा हूं, Z प्राइम नेटवर्क टू पोर्ट नंबर 1 के लिए लिख रहा हूं, तो करंट्स आर व्हाट? I1 डैश एंड I2 डैश आर करंट. सो यहां जो डिपेंडेंट वेरिएबल है, इंडिपेंडेंट वेरिएबल है, वो है I1 प्राइम एंड I2 प्राइम. Independent variables are I1 prime and I2 prime. Correct? What is the second? The second is V1 double prime, V2 double prime, V1 डबल प्राइम एंड V2 डबल प्राइम. अब मैं Z पैरामीटर लिख रहा हूं किसके लिए? पोर्ट नंबर 2 के लिए. और पोर्ट नंबर 2 ये है, तो यहां के इनपुट और आउटपुट वोल्टेजेस, दिस वोल्टेजेस आर V1 डबल प्राइम एंड V2 डबल प्राइम्स आर द इनपुट एंड आउटपुट वोल्टेजेस. सो आई विल राइट V1 डबल प्राइम, V2 डबल प्राइम इज इक्वलेंट टू Z11 डबल प्राइम, Z12 डबल प्राइम, Z21 डबल प्राइम and Z22 double prime. And what are these values? These values are what? These values are I1 double prime and I2 double prime. हमें यहां जो करंट लिखने पड़ेंगे वो करंट किसके लिए लिखने पड़ेंगे? दिस करंट्स आर द करंट्स ऑफ दिस टू पोर्ट. एंड फर्स्ट इक्वेशन में जो करंट लिखे थे हमने, दीज आर करंट्स ऑफ द फर्स्ट पोर्ट. तो बोथ आर वैलिड. Now this is completely we have written the individual two port parameter for the both the two port network. Now if I call this equation as equation number 1, if I call this equation as equation number 2, and if I add this both the equation, now what I want to do, I want to add this two, equation number 1 plus equation number 2. अगर आपने इन दोनों को ऐड किया तो इनके राइट हैंड साइड भी आप ऐड कर देंगे. लीनियर इक्वेशन का रिप्रेजेंटेशन ही है ये. तो आप राइट हैंड साइड भी ऐड करेंगे और लेफ्ट हैंड साइड भी ऐड करेंगे. तो जरा देखें, ये मैट्रिक्स भी है मेरे पास, एक कॉलम है और दो रो है, 2 क्रॉस 1 ऐड कर सकते हैं, सभी के डायमेंशन सेम है. तो यहां लिख देते हैं हम कि अगर मैंने फर्स्ट साइड को जोड़ा तो वो कितना होगा? V11 डैश V1 प्राइम प्लस V1 डबल प्राइम. इन इस साइड को जोड़ा है मैंने. एंड सेकेंड इज V2 प्राइम प्लस V2 डबल प्राइम. दिस इज वन साइड, लेफ्ट हैंड साइड ऑफ द इक्वेशन. और अगर इस इक्वेशन को मैंने जोड़ा है तो यू कैन राइट, यू कैन से V1 प्राइम प्लस V1 डबल प्राइम इज इक्वलेंट टू V1 and V2 prime plus V2 double prime is equivalent to V2. So you can say this value is V1 and this value is equivalent to V2. तो जब हम बात कर रहे थे कि ओवरऑल Z पैरामीटर कितना होगा, तो ओवरऑल के लिए जो डेटा गिवन था वो कितना था? V1 V2 गिवन था. This is V1 and this is V2. So yes, the right hand side is available in the total what is overall. So you can say here I can write the equation. This equation is V1, this equation is V2. Correct? Now what is new here? When you add this two, this is 2 cross 2 matrix, this is 2 cross 2 matrix, you can take okay, one more thing, I1 dash I2 dash. जैसा कि आप देख सकते हैं, we are writing the answer for overall thing, and for overall thing what I can say, I1 dash I2 dash is equivalent to I1, and I2 dash and I2 double dash is also equivalent to I2. So can I say when I am adding this two, can I say Z11 dash, Z12 dash, Z21 dash, Z22 dash, और यहां जो मेरे पास नंबर है वो कौन सा है, I1 dash I2 dash, तो I1 dash I2 dash की जगह मैं लिख सकता हूं this value is I1 and I1 is somewhat we are representing as total, और जो सेकेंड इक्वेशन है आई कैन टेक दिस एज ए Z11 डबल डैश, Z12 डबल डैश, Z21 डबल डैश and Z22 double dash, and this is multiplied by what? Again I can write this value as I1 and I2. From this equation what I can say, I can take this matrix I1 I2 from here, a column matrix is a common. So if you write this V1 V2 is equivalent to, if I take I1 I2 matrix column matrix common, you can add this 2 cross 2 matrix. So this is Z11 prime plus Z11 double prime. First element को first element से add कर दें. This is not multiplication, you are adding. Z12 prime plus Z12 double prime. This value will be Z21 prime plus Z21 double prime. This value is Z22 prime plus Z22 double prime. And this whole is multiplied by what? I1 I2. When you look at the expression, this expression is available in what? This expression is available in standard. This is standard equation. This is the standard equation for what? This is the standard equation. This is the standard equation. This is the standard two-port network. This is standard two-port network. This is the standard two-port network where we also, I can write V1 V2 is given in form of what? V1 V2 is given in form of what? Z11, Z12, Z21 and Z22 multiplied by I1 and I2. Correct? And I can write what is Z11. So you can write accordingly. Z11 is, we can write accordingly. What is Z11? Z11 is given by Z11 prime plus Z11 double prime. How you write the Z12? Z12 is given by Z12 prime plus Z12 double prime. How you define the Z21? Z21 is given by Z21 prime plus Z22 Z21 double prime. And how you define the Z22? Again same. Here this number Z22 is Z22 prime plus Z22 double prime. So this is series connection of two-port networks, and what it says that if you are having the series connection of two-port networks, then you can directly add this. So this is the logic why we can why we are adding this two-port network, why we are adding this two-port network to this Z parameters. Or I can say the in series connection the equivalent Z parameter is given by Z prime and Z double prime. This is the story. Now we will discuss few of the problems on this concept also, but let's go to the next concept. And what is next concept? Next concept says that, what is next concept? Next concept is the concept of one more new parameter. It's time to have one more parameter, and that parameter is known as Y parameter. We will solve few question on this, but after learning 2 or 3 more parameters, and that parameter is known as y parameter. जो अगला पैरामीटर मुझे डिस्कस करना है वो कौन सा है? y पैरामीटर. Let's talk about this. This is the inverse approach. If you are calling z parameter as open circuited parameter, you can say the y parameters are known as short circuited parameter. What do you mean by short circuited parameter? Those we are talking about those parameters in which the independent variable is voltage. You can make voltage equal to 0, means you can replace your input port by short circuit, you can replace your output port by short circuited. These parameters are known as y parameters, or you can say these are short circuit parameters. We can call this parameter set short circuit parameters, or you can call this parameter set admittance parameter. Why we are calling this as admittance parameter? क्योंकि इससे पहले जो हमने जितने भी पैरामीटर देखे तो इसमें आपको जो रेशो मिल रहा था वो किसका रेशो मिल रहा था? V by I का रेशो मिल रहा था. यहां आपको I by V का रेशो मिलेगा, and I by V is what? Admittance. So one more name for this parameter is what? You can call this parameter as admittance parameter, or you can call this parameter admittance parameter. You can call this parameter as also admittance parameter. Now what one more thing about this parameters? Y parameter. Y parameter can be seen as the inverse of Z parameter. Means if I am writing Z parameter like this, if I write Z parameters like this, V is equivalent to Z into I. This is the equation for what? This is the equation for Z parameter. So what is value of I? Suppose I am interested in the value of I. We can write I equal to what? Z inverse into V. This is given in the matrix. For this is not Z, this is 2 cross 2 matrix, Z11, Z12, Z21 and Z22. So when we will bring this here, this value will be what? Z inverse into V. And this Z inverse can be written as Y. How you write it? You can say this Z inverse can be written as Y, and this is Y parameter. This parameter is known as Y parameter. So inverse Z parameter is known as Y parameter. And how we can develop the equation? So we can develop the equation here. If I can be written like this, अगर I को मैं लिखता हूं, if I is equivalent to Y into V. If I can be written as Y into V, so for two port network, और टू पोर्ट नेटवर्क का जो ओरिएंटेशन है करंट का वो हमेशा सेम ही रहने वाला है, उसमें कोई चेंज नहीं है ना. Whether it is two port network, any parameter, this is two port network. So you can say in a two port network, all the ports are having same orientation of current and voltages, like the Z parameter. If this is my two port network, so how everything is defined? This value is I2, this value is, I am calling it V2, I am calling this value as V1, and current which is going inside the network, I am calling this current as a I1. So for this orientation of current and voltages, we can say I1, I2. Always remember this is dependent variable. In two-port network, current is known as dependent variable. Which is independent variable? Always remember this part is what? Dependent variable. And this is known as independent variable. Means you can apply a short circuited input and you can apply a short circuited output. So this value is equivalent to Y11, Y12, Y21. This value is Y22. This much of V1, V2. This much of V1, V2. And this parameter is known as Y parameter. इस पैरामीटर का जो नाम होगा, इस पैरामीटर का क्या नाम होगा? Y parameter. Or I can write in form of equations also. What is the first equation? The first equation we are having here is I1. And what is value of I1? I1 can be written as Y11 V1 plus Y12 V1 plus Y12 V2, or you can say what is I2? I2 is Y21 V1 plus Y22 V2. So this is in form of matrix and this is in form of equation in both. So this is the representation of this linear equation. I1 and I2 are available. Now we have seen one more thing. What is Z parameter? The inverse of Z is equivalent to Y, and both are true. If Z parameter exists and inverse of Y is equivalent to Z, both are true. So let's calculate this. Can I say what is Y parameter? What relationship between Y parameter and Z parameter? Relationship. What this relationship says? Relationship between Y and Z. Y and Z parameter. So relationship between Y and Z parameter, how this relationship looks like? Relationship between Y and Z parameter. So you can say Y inverse is equivalent to Z. I am using this. You can use any, or we can say the Y11, Y12, Y21, Y22, the inverse of Y parameter is also equivalent to Z parameter. And what is Z parameter? Z parameter is given by Z11, Z12, Z21 and Z22. Correct? Now we can take inverse of this. So for taking inverse of this 2 cross 2 matrix, it is very simple. Change the position of this two variable diagonally and change the sign also. I will tell you how you can write position and sign you have to change. So how I can write it? I can write like this. If you change the position, this value will be what? This value will be y22. This value will be y11. You have to change everything diagonally. And here you have to change diagonally sign. So you can write this value is minus of y12. You don't have to swap the variable. Just write y12. If it is plus, write minus. And y21 it is plus, write minus here. Correct? Divided by the determinant of this. And what is determinant? अगर इसका मैं determinant निकालूं तो principal diagonal के जितने भी मेरे पास values हैं उनका multiply कर दे parameters का y11, y22 minus y12 and y21 divided by delta. और ध्यान रखें मैट्रिसेस में अगर आपने डेल्टा का डिवाइड किया है तो हर एक कंपोनेंट डेल्टा से डिवाइड होगा, है ना. सो दिस वैल्यू इज व्हाट? दिस वैल्यू इज इक्विवेलेंट टू z11, z12, z21 and z22. So if I say what is the value of z11, so can I say in the relationship between y and z parameters, what I can say, provided this del is not equal to 0. Provided this del is not equivalent to 0. This del is not equal to 0. This is the condition. So what we want? We want this matrix, this Y matrix should be non-singular matrix. Always remember, del is not equal to 0 is the condition for what? This is the condition for non-singular matrix. If del is equivalent to 0, this is not possible. So this is the condition. So can I say what is Z11? So you can write Z11 can be written as, how you can write the Z11? Z11 can be written as, you can compare this element by element. So Y22 divided by del. This value is Y22 divided by del. What is value of Z12? You can write the Z12 value is, Z12 value is what? Z12 value is minus Y12 divided by del. Determinant, non-zero determinant. And what is value of Z21? Z21 is known as minus of Y21 divided by del. And what is Z22? Z22 can be given by, Z22 can be given by what? Y22 Y11 divided by del. Always remember, whenever I am talking about the driving point impedance, or where I am talking about the driving point impedance, both cannot be negative. What can be negative? This transfer characteristics can be negative. Y12, Y21, this can be negative. Z12, Z21 can be negative. But what cannot be negative? Z11 for a linear network, Z11 and Z22 are the numbers which cannot be negative numbers. So from here, without wasting the time, we can write the condition for symmetrical and reciprocal network. Condition for symmetrical network. And what is the condition for symmetrical network? The condition for symmetrical network says that Z11 equal to Z22, or you can say Y22 divided by del is equivalent to Y11 divided by del. If both are equal, so in case of Y parameter, a Y two-port network can be said to be a symmetrical network if Y11 is equivalent to Y22. And what is condition for the symmetric reciprocal network? Reciprocal network. If you have to comment on reciprocity, if you have to comment on reciprocity using Y parameter, then what we can say, Z12 should be equivalent to Z21, means these two parameters are equal. Z12 should be equivalent to Z21, or I can say minus Y12 divided by del is equivalent to minus of Y21 divided by del. If both are cancelled, so condition for the reciprocal network is also same in the two port Y parameter. Using Y parameter, Y12 is equivalent to Y21. This is the condition. And this whole two port network, you have to remember one thing. Few of the things you have to remember. This should be thumb rule. And what should be the thumb rule? Driving point impedance of a network cannot be negative. How it can be negative for a linear network? Z112, Z11, Z22, Y11, Y22 cannot be negative. But transfer characteristics can be negative due to the direction of current. So this two number can be negative, but what cannot be negative? Y11 and Y22 cannot be negative. If your network is a pure resistive network, always remember, pure resistive network is always reciprocal in nature. So pure resistive network is always reciprocal in nature. So you don't have to calculate. If Y12 is known, Y21 you can directly write. If Z12 is known, Z21 you can directly write. So always remember about these two things. So we have talked about Y and Z parameter. Now let's calculate. Can I say equation for Y parameter is given by I1, I2 is equivalent to I1 is given by Y11 V1 plus Y12 V2. Correct? And how you define the I2? I2 can be written as Y21 V1 plus Y22 V2. Now, what is the idea? Idea is applying a short circuit at input port and output port. So let's apply the short circuit at input port and output port. So I am doing this. What I am doing here, this is our 2 port. This is 2 port network. And we are applying, let's say, we are applying a short circuited output. So I am applying, let's say I am applying a short circuited output. We are applying a short circuited output. I am making independent variable equal to 0. In this case, what is independent variable? In this case, the independent variable is given by, in this case, the independent variable is given by what? In this case, independent variable is V1 and V2. So what I am doing here, I am making V2 equal to 0. And this value is what? I2. And at input we are having V1, and this is our V1 input voltage, applied voltage, and this is our I1. Correct? And this parameter is known as, this is 2 port. So by making V2 equal to 0, how many parameters we can calculate? So always remember which one is independent variable, which one is dependent variable. So we know that I1 and I2, which is written in the left side, are known as dependent variable. So what we have to do? I have to write I1 as function of V1. Here I have to write I2 as function of V2. Or what I can say here I am interested in what? Here I am interested in the ratio of this. By making V2 equal to 0, making V2 equal to 0, what you can have? You can have the ratio of I1 divided by V1. You can have the ratio of I1 divided by V1, and I1 divided by V1 ratio is known as Y11 by making V2 equal to 0. Y11. And what is name of Y11? We can call Y11 as driving point admittance. We can call Y11 as driving point admittance when V2 equal to 0 or when output port is short circuited. So we can call it short circuited input impedance. Or one more parameter is what? One more parameter, by making V2 equal to 0, आउटपुट पे आप शॉर्ट सर्किट लगा के एक और पैरामीटर मेजर कर सकते हो, दैट इज नोन एज I2 divided by which parameter? I2 divided by V1 by making V2 equal to 0, and this is known as not impedance, this is admittance. And we can call this admittance as, this parameters we can call as Y. This 2 will appear here, this 1 will appear here, and we can call this parameter as short circuit transfer admittance. And we can apply the short circuited output. Likewise, we can apply the short circuited input also. So this is the condition by making V2 equal to 0. What is the next condition? तो अगर आपसे पूछा जाए कि Y पैरामीटर में आपको करना क्या है, आप ये तरीका ना अप्लाई करें कि Z पैरामीटर कैलकुलेट कर लूंगा फिर उसका इनवर्स निकाल, डायरेक्ट आप कर सकते हैं. दिस इज द सर्किट बेस्ड प्रॉब्लम. बाय मेकिंग V1 इक्वल टू 0, अगर आप V1 को 0 बनाते हैं, इफ यू मेक V1 इक्वल टू 0, if you apply short circuit at port number 1, if you make V1 equal to 0, remaining two parameters you can calculate. And what are those parameters? Those parameters are करेक्ट. अच्छा, पिछले वाले जो एक्सप्लेनेशन था उसमें आप एक बात का ध्यान रखें कि यहां मैं जब बोलता हूं इंडिपेंडेंट एंड डिपेंडेंट वेरिएबल, तो इंडिपेंडेंट वेरिएबल वो हैं जो आपने सप्लाई दिया है, इज वर्किंग एज अ सोर्स, और डिपेंडेंट वेरिएबल वो है जो आप मेजर करेंगे. तो आप क्या मेजर करेंगे? आप मेजर करेंगे यहां I1 एंड I2. फाइन. बाय मेकिंग V2 इक्वल टू 0 यू विल मेजर V1. तो यहां I1 और I2 एमीटर की रीडिंग्स हैं और V1 और V2 इज वर्किंग एज ए सोर्स. यहां देखिए जरा, ये एक 2 पोर्ट नेटवर्क है. व्हाट आई एम डूइंग हियर, आई एम अप्लाइंग द शॉर्ट सर्किटेड इनपुट टर्मिनल. अगर मैंने इनपुट टर्मिनल पे एक शॉर्ट सर्किट अप्लाई किया है, इफ आई एम मेकिंग दिस टर्मिनल इक्वल टू 0, सो व्हाट आई एम डूइंग, आई एम मेकिंग V1 इक्वल टू 0 एंड दिस करंट इज I1. Correct? This is one 2-port network. और एक ही 2 पोर्ट के लिए आप कितने भी पैरामीटर लिख सकते हैं, देयर इज नो रेस्ट्रिक्शन. दिस वैल्यू इज V2 this value is I2 and this value is V2. How many parameters you can calculate now? अब आप कितने पैरामीटर्स कैलकुलेट कर सकते हैं? तो मैंने आपको पहले भी बताया है कि आप क्या करें, आप करें V1 को 0, आप करें V2 को 0, कैलकुलेट करें I1 and I2 in terms of what? I1 and I2 in terms of V2. तो सेकेंड बार भी तो ऐसे ही करना है, आपको V1 को 0 करना है और I1 I2 का मेजरमेंट करना है इन टर्म्स ऑफ I1 V2 equal to 0. So here I made a mistake. Here I should write V1. तो यहां भी आपको I1 और I2 किसकी टर्म में मेजर करना है? V2 की टर्म में मेजर करना है. तो देखें जरा, what is the next relationship we are having? तो इस बार हमने V1 को 0 कर दिया है और V1 को 0 करने के बाद आप एक पैरामीटर निकाल सकते हैं I1 डिवाइडेड बाय V1, I1 डिवाइडेड बाय V2. By making what? By making V1 equal to 0, and you can call this as transfer admittance. Transfer admittance, and we can say this parameter is nothing but this parameter you can call this is y of 1 2. What is next parameter? अगला पैरामीटर, जब आपने V1 को 0 बनाया तो you can write I2 by V2, I2 divided by V2. By making V1 equal to 0, you can call it this driving point impedance admittance at output, or you can say this is what? This is the output admittance of two-port network. Or you can call it short circuit output admittance. What is short circuited? Input is short circuited. Short circuited output admittance. We can call this a short circuit output admittance. So this is our whole agenda. Short circuit output admittance. Now let's calculate the y parameters of a network. How we can calculate the y parameters of a network? Always what we have to remember? We have to remember something, that in z parameter what is 0? Current, you can make current equal to 0. So you will measure V1 and V2, voltmeter is needed in that case. But in y parameter, what is 0? You are replacing V1 and V2 by short circuited. So V1 and V2 are acting as a source, but I1 and I2 are the readings. The readings of what? The readings of emitter. Now let's go to the next part. And what is next part? Next part here is, let's calculate the y parameter for some network. As I told you, in z parameter, the current I1 and I2 should be independent to each other. Then only z parameter will exist. Likewise, here also, the V1 and V2 should be independent to each other. This is the condition for existence of the z parameter. Existence for y parameter. So can I say condition for a valid y parameter? Condition for valid y parameter. And condition, what is condition for valid y parameter? I will give you one example on this also. Condition for valid y parameters. And what is condition for valid y parameters? The condition for valid y parameter is this. V1 and V2, this is the condition. V1 and V2 should be independent to each other. If V1 and V2 are dependent on each other, then how you will get one value how you will get the parameters which is independent to, means if you are making V2 equal to 0 and that V2 is affecting V1, then you cannot get the two-port parameter network. So V1 and V2 should be independent of each other. Let's take that case. Let's calculate the Y parameter for this network. A network is given by this. This value is V2, this value is I2, correct? This value is R, this value is V1, and input current I am representing it by I1. This is our two-port network. Now what we want to say, our agenda is very clear. First thing is, let's make V2 equal to 0. So let's say I am making V2 equal to 0. Correct? What we are doing? Let's take V2 equal to 0. The moment I take V2 is equivalent to 0 or I apply the short circuit at output, if I make V2 equal to 0, because V2 and V1 are in parallel combination, so V2 equal to 0 will make V1 equal to 0, and if V2 equal to 0 will make V1 equal to 0, your all parameters are infinite in that case. Let's say the first parameter is I am taking V1 divided by I1 divided by V1 by making V2 equal to 0. But what you will say, sir, V2 equal to 0 will make V1 equal to 0, and if V1 is also equivalent to 0, what I can say, this parameter is known as Y11, and Y11 is what? Infinite. Some finite divided by 0 is what? Infinite number. What is the value of, or I should say not define, what is the value of I2 divided by V1 by making what? And by making what? By making, and one more thing, you can say these parameters are not defined, because if you are applying short circuit, this current is also I1 and I2 must be 0. So V2 divided by I1, if both are 0, then there will be no 0 by 0 thing will be there. V2 equal to 0, and this parameter is what? I2 divided by V1, which is 0, and this parameter is also infinite. And same for when you apply, you are taking V1 equal to 0. So can I say for this combination, all parameters are what? Not defined. So V1 and V2 should be independent to each other. If V1 and V2 are dependent on each other, which parameter is not defined? Y parameter is not defined. So V1 and V2 should be independent of each other, then only Y parameter is defined, otherwise not defined. In case of Z parameter, I1 and I2 should be independent to the A. So can I say for this network Z parameter exists because I1 and I2 are independent to each other, but Y parameter do not exist. And let's take case 2. Example 2, not case 2, it's example 2. And what example 2 is saying? Example 2 is saying that, let's say I have this kind of network. This is R, this is R, this is V1, this is I1, this is I2, and this is V2. Correct? What about this network? I can say for this network, Z parameter do not exist. Why Z parameter? Because the moment I make I1 equal to 0, the I1 and I2 are the current of the same branch. If I1 and I2 are current of the same branch, if you make one variable equal to 0, another variable be forced to equal to 0. But here, if I make V2 equal to 0, if I apply a short circuit here, that short circuit will not affect your analysis. If I apply a short circuit here, if I make V2 equal to 0, what you will get? You will get here, you can say the potential drop equal to what? I1 into R. This is the potential drop. So if you apply a simple KVL, here, this value is what? Minus to plus, you can call it V1. And here plus to minus, you can call it minus I1 into R equal to 0. So you can say V1 is equivalent to I1 into R. In Z parameter, we are interested in the ratio of I1 by V1. So you can say I1 divided by V1 ratio, by making V2 equal to 0 equal to what? 1 by R. Correct? One more thing. This parameter is known as Y11 parameter. So this parameter is known as Y11 parameter. Correct? What is Y12 parameter? Do you know that there is a relationship between Y12 and Y21? If I apply a KCL here, the sum of current at a node equal to 0, then both currents are incoming currents. So you can say I1 plus I2 equal to 0. Because I2 is also incoming current, I1 is also incoming current. So sum of these two current must be 0 at the node. So I1 equal to what? Minus of I2. So if I write here V1 is equivalent to I1 into R, you can say V1 is also equivalent to minus I2 into R. Correct? And admittance is not negative. The transfer admittance can be negative because due to the direction, but driving point admittance is always positive. So you can say the I2 divided by V1 is equivalent to what? Minus of 1 by R. And that parameter is known as Y21. Correct? As we know that this network is a pure resistive network, and what is the property of resistive network? The property of resistive network is always reciprocal. So this value is always equivalent to Y12. So Y21 is equivalent to Y12. And this network is a symmetrical network also. If you replace this by here, you will get the exact this type of equation. So you can say Y11 is equivalent to Y22, and Y22 is also 1 by R. So what is the two-port network? Two-port Y parameter. The Y parameter for the network is given by Y11, which is 1 by R. This value is minus 1 by R. Y21 again reciprocal because this is the one resistive network, and this value is given by what? 1 by R. But when you try to convert this, let's use the reverse approach. When I try to convert this Y parameter into Z parameter, you know that the determinant of Y is equivalent to 0. Determinant equal to what? Principal diagonal element is 1 by R into 1 by R is 1 by R square, minus 1 by R minus 1 by R is minus 1 by R square. So determinant is equivalent to 0. This is singular in case, and when your matrix is singular, you cannot calculate the inverse. Means first calculate the Y and then go to the Z parameter. This is also not possible. So always remember the concept is what? In case of Y parameter, V1 and V2, because these are our independent variable, this should be independent to each other. This should not dependent on each other. While in Z parameter, the I1 and I2 should be independent to each other. I hope this is clear. Let's go to, so we have talked about all the conditions of Y parameters. let's go to the next thing. Let's take one more example, and what this one more example says, let's take one more example. Okay, what one more example says, example number 3, it is easy to write, it is easier to write the y parameter for, if a resistive network is given, it is easy to write the y parameter for a delta network. So let's write y parameter of a network. A network is given like this. Let's take by example. I am calling this value as 1 ohm. I am calling this value as 1 ohm. I am calling this value as, you can select any number. 2 ohm, 5 ohm, any number you can select. This is what? This is 1. This is one delta network. This is one delta network, and for this delta network we are interested in what? We are interested in, here we are interested in the y parameter of this network. I am calling this as V2. I am calling this value as I2. I am calling this value as V1. I am calling this value as I1. In which parameters we are interested in? Find out the y parameter of this network. Y, z, you can calculate anything, but we are interested in y11, y12, y21 and y22. We are interested in the y parameter for this network. So, and which connection it is? This is this delta connection. So it is easier to find the y parameter for this. How? Let's go for the first thing. What is first thing? You can make V1 or V2 anything equal to 0. So can I say step number 1? Step number 1, we are applying the short circuited output. हम इसके आउटपुट पे लगा देते हैं एक शॉर्ट सर्किट. तो इसके आउटपुट पे मैंने अगर एक शॉर्ट सर्किट लगाया तो लेट्स सी हाउ दिस विल लुक्स लाइक. This is 1. This is 1. This value is 2. I think this value is 2. Yes, 2. What we are doing, we are applying a short circuited output. So let's say we are applying a short circuit here. We are applying a short circuit here. So we are making V2 equal to 0. We are making V2 equal to 0, and what is current from here? This current is I2. Correct? What else we are having? And at input port we are having two variables. One variable is V1 and another variable is what? I1. Correct? So by making V2 equal to 0, can I say by making V2 equal to 0, if I take this point as my reference point, and if I am taking reference equal to 0 volt, what is the potential of this point? The potential of this point is also equivalent to 0 volt. Correct? So can I say if this current is 0, so can I say if incoming current is I1 ampere is divided into two parts. So this current is between this V1 node. What is the potential of this node? The potential of this node is V1. So can I say this V1, this I1 is divided into two parts. This V1 and 0, and this is also V1 and 0. So can I say this 1 ohm resistance and this 1 ohm resistance will act in parallel combination, or to make difference, if this is taken as 1, you can take this value as 2, so that we can see the visible difference. 1, 2, and let's make this value as, okay, only one change, let's make it 3. 1, 2 and 3. So here also I am making one change. I am not taking this value as 1, I am making this value as 3. Correct? So can I say the resistance, 1 ohm resistance is connected between V1 and 0, and 3 ohm resistance is also connected between V1 and 0. Both are in parallel. Do we know how current divide in parallel combination? So you can say the current will divide here in parallel combination like this. What is this value? This value is 3. So 3 divided by 3 plus 1, 4 times of I1. This is the value of current you can expect in I1. And what is current going here? The current going in this branch is equivalent to, the total current is I1, 3 by 4 I1 is going in this direction. So you can say this current is 1 by 4 of I1. Just the distribution of current. The I1 current is coming, इनपुट से जो करंट बन रहा है वो टोटल I1 है, और I1 V1 और ग्राउंड, अगर दो कंपोनेंट्स के स्टार्टिंग और एंडिंग पॉइंट सेम है, दो कंपोनेंट्स की स्टार्टिंग और एंडिंग पॉइंट सेम है, तो पैरेलल में होंगे, और पैरेलल में जो करंट डिवाइड होगा उसका रूल लगाया हमने. तो यहां से हमारे पास एक दो ऑब्जर्वेशन है. पहला ऑब्जर्वेशन क्या है? द फर्स्ट ऑब्जर्वेशन, यू कैन राइट द केवीएल एट इनपुट. इनपुट का केवीएल कैसे लिखेंगे आप, कि यहां जो पोटेंशियल ड्रॉप होगा वो कितना होगा? 3 by 4 I1 into 1. सो दिस वैल्यू इज 3 by 4 I1. ये गया करंट मल्टीप्लाइड बाय रेजिस्टेंस इज ऑल्सो 1. लेकिन हम इंटरेस्टेड है I1 by V1 के रेशियो में. सो I1 डिवाइडेड बाय V1 रेशियो, दैट करंट I1 divided by V1 ratio by making V2 equal to 0. This parameter is known as Y11. और Y11 का जो वैल्यू होगा यहां कितना होगा? 4/3. हमें चाहिए I1 by V1 का रेशियो. सो दिस इज 4/3 रेशियो. नाउ इस केवीएल ने दोनों काम कर दिए. इफ आई एम इंटरेस्टेड इन द सेकेंड पार्ट ऑफ द, बिकॉज बाय मेकिंग वन इंडिपेंडेंट वेरिएबल इक्वल टू 0 यू कैन कैलकुलेट द टू पैरामीटर. सो व्हाट इज द सेकेंड पैरामीटर वी आर हैविंग हियर? द सेकेंड पैरामीटर इज व्हाट? दिस. व्हाट इज द रिलेशनशिप बिटवीन I1 and I2? सो कैन आई से if I2 current is coming from this branch and net current going in this branch is equivalent to 0 ampere. Why it is 0 ampere? Because 0 minus 0 divided by 0 divided by 2 is 0 ampere. So you can say what is current which is going inside this? This is also I2. So you can say I2 is equivalent to minus of 1 by 4 minus of 1 by 4 of I1. This is the value. If this is the value, we can replace it by first equation. You can say V1 is equivalent to 3 by 4 into I1. And what is I1? I1 is 4 times of I2, and one minus sign is also there. So I am connecting minus here. This value is what? So if you are interested in I2 by V1 ratio, I2 by V1 ratio is what? I2 by V1 ratio is minus of 1/3. Correct? This value is what? Minus of 1/3. So by making V2 equal to 0, we can calculate two parameters, and I will tell you the direct technique to calculate this. So you can say here Y11 parameter, Y11 parameter is what? Y11 parameter is 4/3. You can write what is y11 parameter. Y11 parameter is 4 by 3. What is y21 parameter? So you can say y21 parameter is equivalent to minus of 1 by 3. Correct? We can calculate remaining two parameters by making v1 equal to 0. So let's go to that part also. Step number 3. What is step number 3? Let's say step number 3. So this time we are making v1 equal to 0. So this is and what are the values? Values are 1, 2 and 3. So you can take this value as 1. You can take this value as 2. और यहां वैल्यू में ले लेता हूं 3. अब इस बार की कहानी ये है कि वी आर अप्लाइंग अ शॉर्ट सर्किटेड इनपुट. सो स्टेप नंबर 3 इज व्हाट? आई एम मेकिंग v1 इक्वल टू 0. शॉर्ट सर्किट लगाने का मतलब कि आपने v1 को कितना कर दिया? 0. एंड दिस इज करंट i1. करेक्ट? हियर योर voltage is v2 and you are taking this current as I2. Again the same principle. Due to the short circuit, if I am taking my reference voltage as 0 volt, as you know, you can take any value of, if this value is 0 volt, can I say this value is also 0 volt? So if this value is 0 volt, what is current going inside this resistance? 0 ampere current is going, because what is current across resistance? The current across resistance is always given by the current across resistance is always given by the potential difference divided by resistance. Now this I2 current is going inside the network, so you can say this 3 ohm resistance is connected between this potential V2, so V2 and 0, and this is also V2 and 0. If both are connected between V2 and 0, what is current in this branch? The current in this branch is given by 3 divided by 5, 3 divided by 3 plus 2 into I2. And what is current going in this branch? The current is 1 minus 5 by 3 by 5 is 2 by 5. This current is 2 by 5 times of I2. Can I say if I1 is the incoming current but this current is not going in this 1 ohm resistance, can I say I1 is the current we are having from here? And now we can find the both parameters. Remaining two parameters can be calculated from here. If I apply KVL at this loop, what is potential drop here? 2 into 3 divided by 5 into I2 is equivalent to what? V2. So one parameter is known, I2 divided by V2 ratio, by making V1 equal to 0. Which ratio we are talking about? I2 divided by V2 ratio by making V2 equal to 0. This ratio is what? This ratio is 5 by 6. 5 by 6 more. And what is the value of remaining one parameter? So you can say V2 is equivalent to 6 by 5 times of I2. Or you can say V2 is equivalent to 6 by 5 times of I2. What is I2? I2 can be written as I1, because I1 and 2 by 5 times of I2 is the current in the same branch. So you can say I1 is equivalent to what? Minus 2 by 5 times of I2. This I can write from the KCL. If I write, I can write this from the KCL. What is the value of I2? Minus of 5 by 2. Minus of 5 by 2 times of I1. And this is cancel. This is cancel. This value is 3. So I1 divided by V2 is equivalent to what? Minus 1 by 3. This parameter is Y12. As we know that this network is a pure resistive network, in case of pure resistive network, all pure resistive networks are reciprocal. So we don't need to calculate Y12 because Y12 is same as Y21. You can see here y12 is same as y21. Here the value is minus 1 by 3, and when you go back here it is also minus 1 by 3. So you can say this value is also y12 is minus 1 by 3, and y22, what is value of y22? You can say the value of y22 is what? y22 is 5 by 6. 5 by 6. But this is the standard way of calculating. This is the standard way of calculating all the two-port parameter. But we can do it directly. Let's say I have the data in form of y parameter. I have two-port network. This is the same question, but we will not when we convert this network into the when we convert this into the y parameter, the thing in delta network, these things are easy. So this value is 1, this value is 2, and this value is, I am writing it 3. Okay, can I say this is resistance, and this is resistance. 1 divided by resistance is conductance, or let's say the special meaning to this, let's call this is admittance, because admittance also needs one complex number, but okay, you can write. So what I am saying, if this value is R1, this value is R2, and this value is R3, I am calling 1 divided by R1 as G1 conductance, 1 divided by R2, or let's write it Y directly. 1 divided by R1, I am writing this as a Y1. 1 divided by R2, I am calling this as a Y2, and 1 divided by R3, I am calling it this is a Y3. Now how you can write the y parameter? It's a very simple. If I am calling it y1, if I am calling it y2, if I am calling it y3, how you define the y11? Very simple. y1 plus y2 is y11. Just check your previous case. What is y11? So if this is your question, if R1 equal to 1, so you can say 1 divided by 1 is y1, and this value is what? If R2 is equivalent to 3, so what is 1 by R2? 1 by R2 is 1 by 3, and 1 by 3 is y2. And this value is what? 3 into 1 plus 1 divided by 3. This value is what? 4 by 3. y11 is equivalent to what? 4 by 3. So for delta network, you can write answer directly. What is answer for y11? The admittance of this component, when you add them, you will get y11 parameter. Okay, y12 and y21, because for a resistive network, the resistive network is always symmetrical in nature. If this network is always symmetrical in nature, you can say minus y2, and here also I can write minus y2, because this is a resistive network is always reciprocal in nature. So this is the sign of reciprocal, and you can say this value is 3. Then what is y12 and y21? This parameter is also minus 1 by 3, minus 1 by 3. You can write C from here, minus 1 by 3, 1 by 3. And what is value of this? So you can say the value of, if value of R3, the value of R3 is 2 and value of R2 is 3. So this parameter is written as y3. This parameter is written as y2 plus y3. This parameter is written as y2 plus y3. And this is the standard equation for two-port parameter when the parameters are given in the delta form. So star is very using star you can directly answer the z parameter, using delta you can directly answer the y parameter. And you can see here, if, and always remember y and r are different, or you can call it z and y is different thing. Inverse of z is equivalent to y. So here you can write 1 by 2, here you can write 1 by 3. 1 by 2 plus 1 by 3 is what? 5 by 6. And you can verify from our answer. What was the answer? The answer is 5 by 6. So whenever you are having a resistor or capacitive network or inductive network, try to pure means you cannot do anything in case of you are having dependent sources, but when you are having resistive kind of network you can easily solve this. I hope this is clear. So if this is done, if you have understood it, that this is the direct answer for the two-port network. So how I can write it? If I want to write it, this y parameter for this network, how I will write? I will write like this: 1 divided by 1 plus 1 divided by 3. y11. What is y12 and y21? Because this is one resistive network, this value is minus 1 by 3. And this value is also minus 1 by 3. It will satisfy the reciprocity theorem. And what is value of y22? This value is 1 by 2 plus 1 by 3. You can write the y parameter directly for this network. You don't have to calculate it again and again. I hope this is clear. Now let's take one more example, and what this example says, let me take one example from the y parameter. Okay. Let's take one more example on y parameter. How to calculate the y parameter for a resistive network. Let's say I have this network. Let's say 1 ohm, 2 ohm, 1 ohm, let's say this is also 1 ohm, and here we are having, how we can write answer directly for this network. This is one two-port network, and it is given that this is two-port network, and let's say we are interested in calculating, the y parameter of this network. Let's say we are interested in calculating the y parameter of this network. So I am calling this as V1. I am calling this as I1. I am calling this as V2. And I am calling this current as I2. If you are interested in the y parameter of this network, what is the question? Calculate y parameter. Calculate the y parameter. You can write the y parameter very directly for this question. So what is the agenda? The agenda is try to convert this network into the delta network. So this, when you look at this network is available in which form? This network is available in star form. So let's try to calculate the delta network for this system. Can I say, if I calculate the delta network, here, how delta network will looks like? Let me use this pen. Between here and here, I can use one resistor. From I will convert this star into delta, 1, 2 and 3. I will convert this star into delta. From here to here we will use one more resistance, and from here to here I will use one more. So this is my star to delta conversion. When you want to bring the elements in parallel, always remember which technique is required. Star to delta is required in most of the cases. So what is value of this? The value of this resistance is 1 plus 2 plus 1 into 2 divided by opposite resistance, that is also 1. What is the value of this resistance? The value of this resistance, as you know from our star delta transformation video, this value is 1, this value is 2, and plus 1 into 2 divided by the opposite resistance, that is 1. Here I can write, what is value of this? 1 plus 1 plus 1 into 1 divided by opposite resistance, which is 2. Correct? And next step is your answer. Can I say here, what is value of this 1 plus 2, 3, 3 plus 2, 5. So you can say at input we are having a 5 ohm resistance. What is the value of resistance at this point? 1 plus 2, 3, 3 plus 2, 5. This resistance is also 5. And what is the value of resistance here? 1 plus 1, 2, 2 plus half is 2.5. So you can say 2.5 into 1 divided by 3.5. Means it is parallel of starting and ending point of this red one and this white is same. So you can say this is 5 5s are 5 7s are. What is value of this? This value is 5 by 7. Now your network is available in which form? Star form it is available. Delta form it is available. Which form of which format it is available in? This is available in the delta format. If this is available in the delta format, we can directly write the answer. What is the value of this y11 parameter? The y11 parameter is given by y1 plus y2. So 1 by 5 plus 7 by 5. Always remember, not 5. We are writing 1 by 5. Because we are writing y1 plus y2. So this value is what? This value is the value of resistance, but we are not interested in resistance, we are interested in admittance. So 1 by 5 plus 7 by 5. When you look at what is the value of y12 is given by this value, flip of this value. So always remember, if this is resistance, we can flip to get the impedance, minus of 7 by 5. What is value of y21? As you know that the resistive networks are always symmetrical and always reciprocal in nature. So if this value is minus 7 by 5, you can say this value is also minus of 7 by 5. And when I write the y22 is the summation of these two things. So this value is 1 by 5 plus 7 by 5. You can say this network is reciprocal as well as symmetrical. So that easy to calculate the y parameter for this network. This network is which network? This network we can say is simply a network we have transformed into the delta network, and delta is very easy to deal with the delta network when you have to calculate the y parameter of a network. So I hope you have understood this logic. Let's calculate few more questions for y parameter. Let's calculate few more questions to calculate the y parameter. And this is one of the question. Let's take one question from the from dependent source. Next example using dependent sources. So let me take one example. Okay, I am taking this. Here we are having one ohm resistance, then we are having half ohm resistance, then we are having 2v1. Then also we are having 1 ohm resistance. Then we are having 1/2 ohm resistance. And for this network, we are interested in Y parameters. Which parameters I am interested in? I am interested in Y parameter for this network. So let me call this. So I am saying this value is V2. This value is I2. This value is V1. This value is I1. Correct? And we are having one dependent source also. So how to calculate this? To calculate this, let's make the V2 terminal 0 first. Can I say I am making one terminal 0, that is V2. If I am making V2 terminal equal to 0, if I am applying short circuit at output, how my network will looks like? So you can say network will looks like this. This is 1 ohm resistance. Then you are having 1/2 ohm resistance. Then you are having 2V1. This value is 2V1. And what else we are having? This is 1. And this value is what? 1/2. And what else we can say? We can say that I2, we are making V2 equal to 0. So if I am making this is V2, this is I2, here we are having V1, this I1. And what is our agenda? Our agenda is to make V2 equal to 0. So I am applying a short circuit here. I am applying V2 equal to 0. If I am making V2 equal to short circuit, what is potential here? The potential here is 0. If potential here is 0, can I say, what is this value? This potential value is V1. If this value is V1, what is value going inside this? तो 1 ohm में कितना करंट जाएगा? 1 ohm में करंट जाएगा कि हमने V रेफरेंस को कितना लिया है. सो लेट्स से V रेफरेंस इज इक्विवेलेंट टू 0 वोल्ट. अगर V रेफरेंस की वैल्यू 0 वोल्ट है तो इस पॉइंट का पोटेंशियल है V1 माइनस 0 डिवाइडेड बाय 1. किसी भी रेजिस्टेंस के अक्रॉस करंट लिखने का तरीका है कि पोटेंशियल डिफरेंस डिवाइडेड बाय रेजिस्टेंस. सो हियर पोटेंशियल डिफरेंस वी आर हैविंग V1. सो V1 डिवाइडेड बाय, कैन आई से, if this potential is V1, so I can say this current is V1 minus 0 divided by 1. तो यहां से जो करंट 1 ohm में फ्लो हुआ है, that current is equivalent to V1. Fine. Let's apply what is current from this branch. If this is V1, what is current in this branch? So you can say the current in this branch is I1 minus V1. Why it is I1 minus V1? This is I1 minus V1 because I1 is total incoming current, out of which V1 is going inside this. So this current is I1 minus V1. If this current is I1 minus V1, I can write the potential here. What is potential at this point? So you can say potential at this point is what? This is 1/2 times of I1 minus V1. This is the potential drop across 1/2 ohm. If this is the potential drop across 1/2 ohm, I can I can write a KVL, I can write the potential of this point. The potential is V1 minus I1 by 2 plus V1 by 2. Can I say V1 में अगर इस पोटेंशियल को सब्ट्रैक्ट कर दिया जाए तो मुझे इस पॉइंट का पोटेंशियल मिल जाएगा. V1 इनपुट नोड का जो पोटेंशियल है उस पोटेंशियल में से half of I1 minus V1, half of I1 minus V1 is the current, that is multiplied by half is the potential drop. So input minus this potential drop is the potential of the current source. And what is this value? This value is given by equal to 0 is the potential of this point. So V1 plus V1 by 2 is 3 V1 by 2 minus of I1, not I2, it is I1. Minus I1 by 2. Let's apply the KCL at this point. इस point पे अगर मैं KCL लगा देता हूं तो KCL का वैल्यू कितना होगा? KCL का वैल्यू होगा, I am applying KCL at 3V1 by 3V1 minus I1 divided by 2 node. So what is incoming current? Incoming current is I1 minus V1. I1 minus V1. What is outgoing current? Outgoing current is, incoming current is negative. So I am writing this is minus, this is plus. Incoming current, we will write incoming current negative, outgoing current positive. This current is 2V1. Fine. And potential difference divided by resistance is current. One more current is going away from the node, and that current is 3V1 divided by 2 minus of I1 divided by 2. As you know that sum of current at a node is equivalent to 0. Sum of current at a node is equivalent to 0. So when you write this, minus I1 by 2 is minus 3I1 divided by 2. And this value is 3 by 2 plus 3 plus 3 by 2. 3 plus 3 by 2 is 3 plus half. 3 plus half is 3.5 plus 1, 4.5. 9 by 2. Plus 9 by 2 into V1 equal to 0. And when you write it, the value of I1 divided by V1 by making V2 equal to 0, this value is what? 3. So you can calculate the Y11 parameter directly. You don't need to write a lot of equations, just one equation can solve your problem. Now we are interested in what? We are interested in one more thing. And what is one more thing? Can we calculate the current in this direction? The current in this direction is 3V1 minus I1 divided by 2. And can I say, if the incoming current is I2 but no current is going inside the resistance, because the current across resistance can be written by the potential difference divided by resistance. So potential difference is 0, so current is also 0. So we are having one more equation, I2 is equivalent to these two currents. When I apply KCL here, this is incoming current, this is also incoming current. So I2 can be written as I1 minus 3V1 divided by 2. Now we can have one more relationship. So one more relationship is what? You know that the value of I1 equal to what? 3V1. We want the ratio of I2 to V1 ratio is required. So using these two equations, one equation is what? One equation is I2 is equivalent to I1 minus 3V1. I1 minus 3V1 divided by 2, and another equation is what? I1 equal to 3V1. Equation number 1, I1 equal to 3V1. What is needed when we are calculating the Y parameter? So in calculation of Y parameter, we apply the short circuit at one port and calculate I1 and I2 both in terms of V. So can I say I2 is equivalent to I1 minus 3V1. What is current here? 3V1 minus I1. V1 minus I1 minus 3V1 by 2. Yes. Okay. As you know that what is value of this? We can write here this value equal to 3V1. So 3V1 minus 3V1 divided by 2 equal to I2. So you can say I2 divided by V1 equal to what? 0. So you can calculate, and what this parameter is? This parameter is known as Y21 parameter. So this is the first part of the analysis where you are applying the short circuited output terminal and calculating V1 in terms of I1, I2. What is the next part? The next part is very again the repetition. We will apply the short circuited input. So if you apply the short circuited input, how your network will looks like? This is 1 ohm 1 by 2. Let me apply short circuited input. So this is This is 1 ohm. This is 1 by 2. One ohm, 1 by 2. What else? 1 ohm, 1 by 2. If you are making V1 equal to 0 and this is voltage dependent current source, so I will make current source equal to 0 and current source equal to 0 is what? Open circuited. Now you are having 1. So you will replace your current source by open. So this 1 resistance will appear in series. So I will write 1 here. And what else we are having here? 1 by 2. Again, this is which network? Delta network. But this delta network is for some condition. By making what? We are making V1 equal to 0. If you are making V1 equal to 0, this current is what? I1. And this value is what? V2. This value is what? I2. Suppose I want to calculate which parameter? Suppose I want to calculate V2, I2 by V2 ratio. It's a very simple. If you are interested in current in this branch, the current in this branch is given by 1 plus 1 by 2 is 3 by 2. So you can say this current is 3 by 2 divided by 3 by 2 plus 2 is 2 into I2. So this current is what? This current is 3 by 4 times of I2. If this current is 3 by 4 times of I2, what is current in this branch? One current is 3 by 4. Another current is 1 by 4 times of I2, so that the sum of current equal to 0. And if you are replacing it by 0, the 0 current will enter into this branch. So this current is what? I1. The moment you write it, you can get the answer in the same time. So what is V2? V2 can be written as 3 by 4 times of I2. This is the current in this branch multiplied by half. So I2 divided by V2, that is the value of Y22, and this value is what? 8 divided by 3. And you can write it directly also. And what is the value of value of another quantity. So you can say V2 is equivalent to 3/8 times of I2. And what is the value of I2? If I apply KCL here, I1 is equivalent to -1/4 times of I2. So I2 is equivalent to what? -4 times of I1. If I write minus of 4 times of I1 here, you can say I1 divided by V2 value by making V1 equal to 0 is Y12, and this value is minus of 2/3. You can write directly. So this is the idea. This is the idea to calculate the Y parameter for a given network. Correct? What is one more thing we can write? Okay. So this is the Y parameter for the network. So when your network is resistive network, it's better to get when your network is resistive or all capacitive or inductive in S domain. So first we will take Laplace transform, and after taking the Laplace transform, just try to write answer directly. In most of the question they will ask in this format only. Now let's go to the next part, and next part is what is the connection of Y parameter. So we can get the connection of Y parameter also, but this connection we will discuss the connection of Y parameters in tomorrow's class. In this connections we will see if you connect the Y parameter in parallel, what will be the resultant of that in that case. And then we will talk about ABCD, H and Z parameters, and we will see the connections of these parameters also. I hope you have understood today's class. Thank you.